Okay, sorry, I accidentally hit the lock screen on my iPad, so it stopped recording. But that's fine. I'm just gonna upload both of these and start where I left off. Okay. So now the domain of this circle will be all the x values from left to right that are on the circle. So you just start at the far left point here, this is the far left point, and that x value of that point lines up with -7. And then you go to the far right point, and that point goes to +1. So the domain from left to right would be from -7 to +1. And they both would have brackets because they're on the circle. So it's included. So that's from left to right. And then the range is from bottom to the top. Use a different color there. Bottom to the top. So you find the smallest y value there. That y value is -2. And then the largest y value of that circle is a +6. So that range goes from -2 to +6, from bottom up, least to greatest. Okay, so that's that one. Excuse me. All right, now we're going to talk about piecewise functions. So it says graph each function for the given domain only for piecewise functions. So that's what a piecewise function does. It separates this into two equations for a specified domain. So these are the domains here for each piece. So for the first piece, we have y equals -3/5 x plus 2 for x is less than 4. So what I'm going to do is figure out what's happening at this end point. At x is 4. So when x is 4, I get -3/5 times 4 plus 2. So that'll give me -12/5 plus 2. And I can make that a fraction, multiply by 5 to get a common denominator. So this will be equal to -2/5. Now on your final exam, this won't give you a fraction. So, and if it does, you can just type in -2 divided by 5 and get a decimal and then plot it on Pearson. Okay, so that point is around 4, -2/5 is between 0 and 1. So that'd be around right here. And that's going to be an open circle because it cannot equal 4. Strictly less than 4. We plugged 4 in for the first piece, just so we could see what was happening. And then I have to pick a value less than 4 because I need to go towards the left because of that domain. So I could pick 0. That's an easy number to choose. And if I plug 0 into there, I would get 2. That's my y-intercept. So that point would be right here. 0 is in that domain. So I would only graph that line this way because that's the direction of all x values less than 4. But I still needed to figure out what was happening at 4 so I could put my open circle. This is my open circle at 4 for line 1. Line 2 is y equals 2. For all values greater than or equal to 4 for x. So y equals 2 is a horizontal line. So at x is 4, y would be 2 because it's always 2. So 4 comma 2 would be right here, and that would be a closed circle because it can equal 4. X can equal 4. And then I'm only going to plot this line to the right because I'm only graphing that second piece of the piecewise function for all values greater than or equal to 4. And that's a horizontal line at y equals 2, so it looks like that. Okay, and then it's asking about the range here of the piecewise function. So the range, you're always looking at the function from bottom up. So the lowest y value I see is the one here for this point, which was -2/5. And it's an open circle, so it's not included. So that gets a parentheses. And then that line goes up forever, so it'll have all the y values. So this is the range, -2/5 to positive infinity. Again, because this one's going up. It even has 2, so I don't need to worry about this because that's all 2 for y. But it keeps going up, up, up. So that's my range, bottom up. Okay, number 5 says to find the vertex and determine whether there is a maximum or minimum value and find that value, find the range, and find the intervals on which the function is increasing and decreasing. Graph the function. So this is when we learned about all those properties of quadratic functions. So this is my quadratic function. And a is equal to 2, b is equal to 8, and c is equal to -1. So remember to find the vertex, and I have it up here. You use this formula. This is what we use to find the x-coordinate. So the x-coordinate of the vertex is going to be equal to the -b, which is going to be -8, divided by 2 times a, which is 2. This is how you find the x-coordinate of the vertex. So simplifying this would give me -8/4, which is -2. And then I'm going to plug that value into the function to find the y value of my vertex. So I'm going to plug in -2. to find the y value of my vertex. So I'm plugging it into this function here. So this would be 2 times negative 2 squared plus 8 times negative 2 minus 1. Negative 2 squared would be a positive 4. 4 times 2 is 8. 8 times negative 2 is negative 16. 8 minus 16 is negative 8. And negative 8 minus 1 is negative 9. Just making sure I did all my work right here. Okay, so the vertex would be the ordered pair negative 2 comma negative 9. All right, so I'm going to go ahead and plot that on this graph. Negative 2, 1, 2, negative 9 would be all the way down here. And because A is positive, because 2 is positive here, that tells me that my parabola is opening up. So it looks something like this. And more specifically, it would look like this, because I know that the y-intercept will be negative 1, because if I plug x as 0, then that would just leave me with negative 1. So it'll actually be crossing right there. It's a little bit narrower. And the axis of symmetry is always the vertical line that goes through the vertex. So that would be x equals negative 2. This would be a minimum value. And the minimum value is always equal to the y value there, negative 9. Smallest y value on your function. So this would be negative 9 for the minimum value. The range would start at that minimum value and would be included negative 9 to positive infinity. Range is the y values. The domain would be all real numbers. I'll write that down here. The function would be increasing from the x value of that vertex going to the right, because it's going up there. So that would be from negative 2 to infinity. And then it's decreasing from left to right on the left, because it's going down from left to right there. And that would be from negative infinity to negative 2. Okay. Okay. All right, so the next one is about polynomial functions. So here's a general form of a polynomial function, and it's in its factored form there. So the opposites of the B1, B2, B3, those would be the zeros. So negative B1, negative B2, dot, dot, dot would be the zeros. Always the opposite sign of the number inside the factor, because that's what makes it 0. And then the exponents on each factor, if it's in its factored form, these are the multiplicities of those zeros. Okay, so if I look at this polynomial, I'm only looking to find the zeros of this example here. I'm looking for what makes these factors here equal to 0. I don't care about this coefficient here. That's not a part of one of my factors that will make it 0. But negative 2 here will make this one 0. Negative 2 plus 2 is 0. So that's a 0. Positive 3 minus 3 is 0. So positive 3 is a 0. Positive 3 minus 3 is a 0, but I already got that one. And then this one, x would have to be negative 1 to make that 0. Negative 1 plus 1 is 0. So if you're looking at these, it's always the opposite signs. Now, this can be rewritten as negative 1/3 times x plus 2 times x minus 3 squared, because there's 2 of the x minus 3's. So that's equal to x minus 3 squared. X minus 3 times x minus 3 is x minus 3 squared. And then x plus 1. So the exponent on the other two zeros are just technically 1. Just don't see them, because if it's 1, we just don't write it. Those are 1. Okay, so it says the multiplicity of the smaller 0. So smaller 0 just means which one of these was the smallest number. Negative 2 was the smallest number out of 3 and negative 1. So the multiplicity of the factor of negative 2, where that came from, is here, which is 1. Because that's the exponent. So that's the smaller 0. Multiplicity of the larger 0, that would be the 3. That's the largest number out of those 3 zeros. And that multiplicity was 2, because that's the exponent of that factor, where that 0 came from. And then the last one, multiplicity of the middle 0, would be the negative 1, and that would also be 1. So first, let's plot these zeros. So negative 2 would be right here. Positive 3 would be right here. And negative 1 would be here. And we're going to graph this using the multiplicity. So for the smaller 0, or the 0 equal to negative 2, the multiplicity was odd, because it's 1. Multiplicity was odd, which means it'll cross at that 0. And then for the 0, positive 3, the multiplicity is even, because it was 2. So it'll touch or bounce and then go back for the way it came from. And then for the 0, negative 1, the multiplicity was also odd. So it'll cross. And then the end behavior, we need to know what the leading term is. So first of all, I know that my leading coefficient is going to be that negative 1/3. Because if I were to multiply all of this out, that is the only number, out front, and there's no other numbers in front of those x's. So my leading coefficient would be negative 1/3, and the leading term would be negative 1/3 times x to the 2/3 power. And I got that by adding all these exponents up. So we talked about how to do that when we learned about polynomial functions. So the degree is even, which means the end behavior is going in the same direction, and the coefficient is negative. So that means that the end behavior is looking like this. I'll put that over here. So I gave you a chart for that when we talked about polynomial functions, which you can have on your piece of paper. So what does that tell me? That tells me I know that these end intercepts are both going down like that. That's my end behavior. And then for the 0 of -2, it's crossing through. So it's going to go up and cross through. It has to come back down, and it crosses through -1 as well. And then it has to go back down and come back up at some point. And then at 3, it bounces, just touches it and goes back down. So it looks something like that. And then, of course, you could find some more precise points by plugging 0 in for x and finding the y-intercept, just to be more precise. But this should help you narrow it down because it'll be multiple choice options. But let's just see what f of 0 would be. This would be -1/3 times 2 times -3 times -3 times 1. Because if I plug 0 in for all those x's, the x's would just go away. And all of this would become multiplied by each other. And that will leave me with -6. So really that point would be down here. Just to be a little bit more precise. So you could check some points using the graphs they give you to narrow it down even further by just plugging points into that function and plugging values of x into that function and solving for y. Okay. So the next one is about exponential functions and logarithmic functions, but we're going to start with exponential. So we just recently did this, so it should be pretty fresh in our memory. So it wants me to use transformations of the base graph 3 to the x to graph the given function. So that's my base graph. So if we remember, for the exponential function, it's going to look like this, which always goes through the point 0, 1. And that would be 1, 3 right here. If I plug 1 in for x, that would give me 3. And then this function here, f of x equals 3 to the x minus 2 power, is just subtracting 2 from that x. So that is a horizontal shift. So this is the graph of 3 to the x shifted to the right 2 units. And so those points that I had there will all shift to the right 2 units. So 0, 1 will become 2, 1, and 1, 3 will become 3, 3. So it'll look something like this. Wait, it's the wrong point. That is 1, 2, 1. That's correct. And 3, 3 would be right here. And then it wanted me to figure out the equation of the asymptote. So remember, these base graphs always have, of exponential, always have the horizontal asymptote of y equals 0. So we didn't move this function up or down at all. So the horizontal asymptote will still be y equals 0. Okay. All right, so the next one is rational functions. So remember, for rational functions, we cannot divide by 0. So any values of x that make the denominator equal to 0 will not be in the domain of this rational function. So that's how we find the domain. It's going to be all numbers except for any values of x that makes this denominator equal to 0, which would be 5. X cannot equal 5. And these values create vertical asymptotes that the function will never touch because they're undefined, because they make the denominator equal to 0, and that's bad. So therefore, the domain is equal to all real numbers except the values for x that makes the denominator equal to 0. Okay, so to find the domain of a rational function, I take that denominator, x minus 5, and I set it equal to 0 to figure out what value makes that denominator 0. Because if I want to know when is that equal to 0, then I would set this equal to 0 and solve. So I would add 5 to both sides. So x cannot equal 5, like I said. Of course, if you could probably see that, 5 minus 5 is 0, and that's bad. So the domain is all real numbers except for the value x equals 5. So in interval notation, that would be from -infinity to 5, with a parentheses because it can't equal it. Union, 5 to +infinity, with a parentheses because it can't equal 5. All All right, to find the x-intercepts of a rational function, we set the numerator equal to 0 and solve. So x is equal to -3 is an x-intercept, which comes in the form of a point -3, 0. So that's my x-intercept. The y-intercept, we plug 0 in for x. So that would be 0 plus 3 over 0 minus 5, which is 3 over -5. So that's my y-intercept. And that would be in the form of a point 0, 3 over -5. The vertical asymptote, which is the vertical line that the graph will never touch, is the x equals 5, because that was the value that made the denominator equal to 0. The horizontal asymptote came from those 3 rules I gave you about the degrees of the numerator and the denominator. So our function, they have the same degree on the top and the bottom, because the degree of x is 1 and the degree of this x is 1. So the horizontal asymptote will be the same thing you see right in front of it, which is 1 over 1, which is just 1. So that would be y equals 1. So you can have those 3 rules written on your sheet. And then this graph would have no oblique asymptote, because that only occurs if the degree on the top is 1 more than the degree on the bottom, but these are the same. So let's graph this. So the x-intercept is -3, 0. The y-intercept is -3 over 5, just like right here. The vertical asymptote is x equals 5. So that's the invisible line that the graph will never touch, because x cannot equal 5, because it makes the denominator equal to 0. The horizontal asymptote is y equals 1. Remember, a function can possibly cross the horizontal asymptote. And these lines are invisible, so they would just be dotted lines in your multiple choice answers. So you're just looking for those 2 dotted lines that line up with the vertical and the horizontal asymptote. And then we already found all the possible x-intercepts. So I know that this is just going to, I know that this side is just going to come down like this. And it'll never cross that vertical asymptote. And then what you could do is plug in -5 here to see what the graph's doing at -5. So that'd be -5 plus 3 over -5 minus 5. This would be -2 over -10, which would be +1/5. So that would be about right here. And so this is just going to get really close to that horizontal asymptote, but it's not going to touch it. And then you could plug in a point over here to see what's happening, like 6. Give me 6 plus 3 over 6 minus 5, which is 9 over 1, which is just 9. So that gave me the point 6 comma 9, which is up here. So it's above those asymptotes. That tells me it's going to look something like this. Okay, and then you could also, of course, plug that whole thing into your calculator on the right side and use your graphing calculator to check, because these will be multiple choice. Okay, number 9, write an equation for a function that has the graph with the shape of y equals square root of x, but shifted left 5 units and up 2 units. Then find the domain of the function. So they're giving me this base graph here, function, y equals the square root of x. And they want me to find the equation of a graph that has that shape of the base graph square root of x, but shifted left 5 units. So if I shift something left 5 units, that will be adding 5 directly to the x. So that would be the square root of x plus 5. And then up 2 units would be on the outside of the square root, because a vertical shift is always on the outside. So this would be the equation of the graph that has the shape of the square root of x. So I want to keep the square root of x in my equation here, but shifted to the left 5 units. So that's adding 5. And then up 2 units is adding 2 to the outside of the function. Now the domain of a function that has a square root are all values of x, except for the ones that make the expression underneath the square root negative. So to find the domain, I need to set x plus 5, which is the expression under the radical, greater than or equal to 0, because it needs to be greater than or equal to 0. It can't be negative. It can be 0, but it can't be negative. So I subtract 5 over. So x has to be greater than or equal to negative 5. This is the domain. And in interval notation, that would be from negative 5 with the bracket, because it can include it, to positive infinity. So that's my domain in interval notation. Number 10. So number 10 says, for the given function, find f of g of x. This is not f times g. It's an open little circle. So this is composition functions. And find g of f of x and the domain of each. So f of g of x is the same thing as plugging in g of x into the function for f. So f of g of x. So I'm going to take g of x, which is the square root of x, and I'm going to plug it into f, where I see that x. So this is the same thing as f of the square root of x, which this notation here tells me to plug the square root of x into f, everywhere I see an x. So this would equal to 5 times the square root of x minus 2. And that's it. The domain of this would be from 0 to infinity, because the only restriction is that x underneath the square root can't be negative. So it can be 0 and anything greater than 0. Okay, and then the next one would be g of f of x, which is going the other way. That's telling me to plug f of x into g. And f of x is equal to 5x minus 2. So now I'm replacing 5x minus 2 into the function g of x. So this would be the square root of 5x minus 2. So I'm just replacing the x in g of x for 5x minus 2. So to find this domain, all of this underneath that square root needs to be greater than or equal to 0. So I add 2 to both sides. And then I divide by 5. So the domain would be all numbers greater than or equal to 2/5. Okay, number 11, for this function, wants me to determine whether it's 1-to-1. If it is, find a formula for the inverse. So if you plug this into your graphing calculator, the graph will look like this. And this is 1-to-1 because it would pass the horizontal line test. Nothing's repeating, it's constantly increasing from left to right. So to find the formula for its inverse, I can rewrite this as y equals x cubed plus 5. And then I will switch my x and my y variables. And then I will solve for y. So that leaves me with x minus 5 equals y cubed. And then you need to take the cube root of both sides. So y would be equal to the cube root of x minus 5. So this would be, last step, I need to replace y with the inverse notation. So that would be the answer. Okay, the last section is inequalities and systems of inequalities. Am I missing a page here? Okay. So the first one says to solve and write interval notation for the solution set, then graph the solution set. So this is 2 linear inequalities and 1 variable. and they want me to write my solution set in interval notation. So this is what we did first, more towards the beginning of the course. So I'm going to solve both of these separately. So add 2 to both sides. So -3 plus 2 would be -1, and then I'll divide both sides by 7. So x will be less than or equal to -1 over 7. Or, for the other one, I add 1 to both sides. So 4x would be greater than or equal to 8. And then divide both sides by 4. So x would be greater than or equal to 2. Okay, so this is an OR, so I'm going to include both on my number line, both solutions. So -1/7, and then 2 would be there. So the first one says that x has to be less than or equal to -1/7. So that would get a bracket because it can equal it, and then I would shade to the left because that's less than -1/7. Or x is greater than or equal to 2. So that's shading to the right because that's greater than or equal to 2. And that would also get a bracket because it can equal. So in interval notation, this would be just reading this number line from left to right would start at -infinity because it's going in the -infinity direction up until -1/7 with a bracket, union, bracket 2, comma, infinity. Number 2, solve and write interval notation for the solution set, then graph the solution set. So this is an absolute value in an inequality. So remember that with absolute value, if it's less than, I need to take everything inside my absolute value and set it between the +4 and the -4. If it's less than. If it was greater than, I separate it into 2 inequalities with the OR symbol. So you can find those rules in the, I can't remember what section that was, but we went over it, so it would be in my notes. I want to say it's chapter 4. I can't remember off the top of my head right now. So to solve this, I'm going to add 2 to all 3 sides. So that will give me -2 on the left and 6 on the right. And then divide each side by 3. So final answer would be this. And on a number line, I'd plot the -2/3 and then the 2. And then this is between, x is between these two. So, and it can equal both. So it'll look like this. Oh my gosh. An interval notation, this would be from -2/3 to 2 with a bracket. So that would be the answer in interval notation. All right, and then the very last thing would be linear inequalities in 2 variables and systems of inequalities. So make sure you watch the video for 6.7 to review those. And then that would be the last video for the final exam review.